All right, so what is a liposome? This is a question that I do get asked a lot, and it is quite a simple concept. Because it's a simple concept to explain, it means it'll be simpler for you to explain if someone asks you. Now, the basic unit of a liposome is a phospholipid. Now, this is what a phospholipid looks like. It has a hydrophilic head and a hydrophobic tail. Now, the science words may sound a little bit scary, but just remember that science words typically explain what they're talking about. So, if you look at the word hydro means water and phobic means fear, so it only makes sense that the hydrophobic tail is the one that doesn't like water, and the hydrophilic head is the one that does. And for those a bit more science savvy, a phospholipid is a polar group connected to a phosphate, connected to a glycerol, which in turn is connected to two fatty acid chains. Now, as you guys all know, fats and waters don't like each other, so it only makes sense that the fatty acid chain are the ones that are hydrophobic. Now, this matters inside the body because, as we all know, the body is made up of mostly water. And if these phospholipids are in an aqueous environment, which the body is, the phospholipid will orient itself so that the hydrophilic heads, the water-loving portion, faces out towards the water, and the hydrophobic fatty acid chains face into the middle, hiding away from the water. Now, this is a phospholipid bilayer. This is pretty much what a cell membrane looks like, a bare-bones cell membrane. If you want a bit more visual of a cell, this is basically a cross-section of what a cell membrane looks like. Everything on the inside of the circle is the inside of the cell, and everything on the outside is, well, the outside. Now, this is a cell membrane, and there are three main ways that I want to touch on for a nutrient to enter the cell. One is diffusion. This typically happens when the nutrient is fat soluble or is really, really small. Now, fat soluble means that the thing wanted to enter can dissolve in fat. And if it can dissolve in fat, it means it can dissolve right through this fatty membrane and go right into the cell, no problem. The second is the help of transporter proteins. Now, typically this is when the nutrient entering is water soluble, like most vitamins, meaning that it dissolves in water, or if it is very large. So there's no way for it to cross the membrane without any help, and I'll get back to that in a second. The third is through a liposome, which is a form of aided transportation, and is by far the most efficient way for a water-soluble or large nutrient to get into the cell, especially if they are consumed in a way that they're already inside a liposome. Now, just quickly jump back to the second means, the aided transportation. If the substance entering the cell is water-soluble or very large, it needs help crossing the membrane. And this help is in the form of transporter proteins, so these purple things. And although it is a very efficient means of cellular transportation, it does rely heavily on other means of metabolism. So since the nutrient itself has to be broken down to the perfect shape or size to fit into these transports. And so when taking vitamins or supplements, it is this extra metabolism that can result in such poor absorption rate, which results in most of the vitamin or supplement you're taking just to be peed out and causes expensive urine. And so now hopping back, this is a cell membrane. If this is what the cell membrane looks like, then this is what a liposome looks like. I'll give you $10 if you can tell me the difference. You can't, because they're literally made of the same thing, a phospholipid bilayer. Pop it into a 3D kind of structure, and this is kind of what you get. It's a hollow sphere, if you will. And now what Vasayo did is they took this liposome and simply popped a nutrient inside, which is pretty cool. And that's all dandy, but how does it work? Well, I'm glad you asked. Quite simple. So a liposome, once it reaches the cell membrane, it literally fuses with the cell membrane, and because it's part of the same thing, and it spills its innards inside, if you will. Now, I know most of you guys are visual learners, so here is a video that I found online. As you guys all know, if you've cooked or just simply put oil inside of water, this is what happens. And it is, if you imagine that the droplet two droplets beside each other are a liposome and a cell, once it enters, it literally just fuses into one, as you'll see, just sucks it kind of in. And here you'll see a better one of the two big ones. Once this one right here is a liposome and this one here is a cell. Once they touch, the membranes literally fuse together and they go into one big one. And so you may ask, well, if that's what happens, won't my cells explode? Well, not really. The short answer is no, it doesn't, because liposomes are used in the body to do other things in the cell, and so the way that liposomes bring stuff into the cell is actually the same way that it takes things out. So that's the way it removes waste from the cell. And so the membrane size is in a constant flux of shrinking and growing, so you don't really have to worry about if you take too much, will my cells explode. Another cool thing your body does is it can use the phospholipids inside our cell membranes to combat things like aging and inflammation, which further helps to keep the appropriate size of this cell. And so this means that when you're taking a supplement from Vasayo, for example, you won't just get the benefits from the high quality nutrients inside, but also from the liposome itself that it comes encased in. But that is actually a video for another time. So hopefully this was quite helpful. Enjoy.